Hello, I am Nitesh Pradhan from LabVIEW Programming. It is a video number 8 of the series of LabVIEW signal processing. In this video, I will show you how can we plot two-side Fourier transform using the Real FFT VI. Okay, so for that, let's start our designing. Come into the front panel, right click, take a numeric, frequency, SZ, duplicate it, sampling, F for frequency. Okay, then after take one more number of sample. Convert the representation into I32 bits to remove corrosion effect. Right click here. Now come into the block diagram. First of all, right click, come into the signal processing, drag it. In the signal processing, you will get the waveform generation. In the waveform generation, you will get the sine wave VI. In the signal generation. In the waveform generation, you will get the sine waveform. In the signal generation, you will get sine wave.vi. So take sine wave.vi, connect the number of sample with this VI. Now right click, take a divider, frequency divided by sampling frequency and connect with the frequency. Now we need frequency spacing. Frequency spacing means del T. Okay. Why we need frequency spacing? I will tell you later. Now it will generate a sine waveform. Right click, come here and come into the signal processing, come into the transformations and FFT. Take the FFT here, label FFT. Now come into the polymorphic and take this real FFT only. Okay. After the selecting real FFT, close the polymorphic selectors. Okay. One thing which I want to say, if you want to count, so many times we need to count how many samples are present in the sine array. So you can directly take this number, either you can take the array size and you can find how many samples are present in sine wave. So no need to take this functions. This function is unnecessarily. Now take FFT, take a divide functions, and divide with the array size. Okay, divide with the array size. Now right click, come into the mathematics, complex complex to polar functions. Take this one. Connect with the output of this divide functions. Here we can connect one output to check the here we can connect the output to check the sine waveform value. Okay, so take a waveform graph here and connect. Nice. You can connect here. After that, now we need to plot the power spectrum density concepts. Okay, frequency spectrum. Okay, now we need to plot the frequency spectrum. Here we can plot the just second. No need to connect here. It was wrong. We need to connect here, and here we can connect for the FFT. Okay, so it will be a sine wave, and it is FFT, real FFT, real FFT. Now I need spectrum, frequency spectrum. So to plot that frequency spectrum, come here and take this bundle functions, right click, take a constant. As you know, and waveform graph is the graph is a waveform graph is combination of del t, sorry, t0, del t and y array. T0 means start time, del t means time difference, and y array that contain all kind of the input value, sorry, all kind of the amplitude or function value. Let's take a divide functions. By dividing the sampling frequency with the number of sample. Okay, now using this way we are creating frequency spacing. Okay, the output name will be a frequency spacing. Just a sec. Okay, right click in the wire, label frequency spacing. After that, connect with the real. Okay, now come into the front panel, take a write down here spectrum. Now come into the front panel, keep the frequency 10, sampling frequency 100, and number of sample also 100, and run. Okay, so no need to plot this real-time FFTs because we cannot change, okay, the value if you want. So you can connect this value here with the real value to observe some output, right? Control B. So in this way you can write, okay, so in this way you can plot two-sided or single-sided FFT Fourier transform, okay, two-sided Fourier transform of a signal using real FFT VI, and you can observe the arising of frequency spectrum. Means, okay, this is experiment for the to display two-sided. You can delete this portion also, and one-sided using the real FFT VI, and you can observe the spectrum. So here this is for the spectrum and this is for the sine wave, okay.